Hello and welcome to 2026 eCosta session EV274, Multivariate and High-Dimensional Methods. My name is Mark Zanecki, and in this presentation I will be introducing Tri-Signal PEA, our new AI-enabled predictive equity analytics with dynamic state space framework, and applying it to hedging for equity benefit guarantees in life and annuity insurance products. This cutting-edge tool is designed to help investors navigate the unpredictable nature of the financial markets by providing insights to avoid market downturns as well as capture upturns. Traditional approaches to equity analysis fail to consider the complex and evolving dynamics of the market. However, our dynamic state space framework takes into account the constantly changing market conditions to deliver accurate and timely predictions. With Tri-Signal PEA AI-enabled predictive equity analytics with dynamic state space, investors using change point detection can identify market downturns in advance, allowing them to take proactive measures to protect their portfolios from significant losses. By understanding the underlying trends and signals, they can make informed decisions to reduce exposure to risky assets or adopt defensive strategies. Furthermore, our framework enables investors to capture upturns by identifying emerging trends, market opportunities, and undervalued assets. By staying ahead of the curve, investors can take advantage of positive market movements to maximize their returns. Tri-Signal PEA-AI-enabled predictive equity analytics with dynamic state space leverages advanced algorithms, machine learning, and big data analysis to provide accurate predictions. Key features include 1. Dynamic state space framework. Our framework adapts to changes in the market environment and aligns with the evolving dynamics of equity markets. 2. Risk mitigation strategies. Our tool provides insights that identify downturns, manage risk exposure, and implement effective risk mitigation strategies. 3. Opportunity identification. By analyzing a wide range of market indicators and patterns, our analytics help investors uncover upturns and identify investment opportunities that otherwise would be overlooked. Make smarter investment decisions with Tri-Signal PEA AI-enabled predictive equity analytics with dynamic state space and stay ahead of market trends. By avoiding market downturns and capturing upturns, investors can enhance their returns and achieve their financial goals with greater confidence in the shortest amount of time through compounding of returns. Outline we will follow. 1. AI-enabled predictive equity analytics, model, signals, concepts, change points, retrospective and prospective. 2. Distribution ink blots as informative, leading to discrete approximation to Fokker-Planck equation. 3. Current hedging of life and annuity products. 4. AI-enabled predictive equity analytics, hedging for life and annuity products. Download of sample Excel models available at https://trisignalpia.com. Section 1. AI-enabled predictive equity, analytics, model, signals, concepts, change points, retrospective and prospective. Signals. AI-enabled predictive equity analytics with dynamic state space is based on a time-varying form of a Merton-like return equation. At the end of each trade day, we observe the close price and estimate the drift term, volatility, and outlier point mass indicator. We shall designate signal 1 to represent combined volatility and Poisson outlier point indicator for signal 1, strength less than 1. Signal 1 strength equal to 1 represents pure Poisson point outlier occurrence. We designate signal 3 as drift. You can see that in AI-enabled predictive equity analytics with dynamic state space framework, momentum is defined as the change in the rate of drift. This differs from standard momentum definitions. We will see in coming slides that a 3x3 matrix representing 9 state spaces will form our eigenvalue, eigenvector analytic foundation. Prospective signal 1, drift. Prospective signal 3, local variance, and retrospective change points are informative signals for any equity time series. Pictured for stock JPM and mutual fund FAMVX are prospective signal 1, prospective signal 3 drift, and retrospective change points from January 2026 to mid-March 2026. As equity series up and down movement increases, we observe signals 1 and 3 displaying higher frequency and intensity with similar retrospective signal behavior. A constant level time series produces no prospective nor retrospective signals. AI-enabled predictive equity analytics, PEA, defined. Simply, it is the capability to retrospectively as well as prospectively predict, detect change points, and associated subsequent time series behavior for ETFs, mutual funds and stocks with high accuracy. This is commonly referred to as alpha signal prediction, detection in as little as one elapsed trade day. When significant signals are present, AI-enabled predictive equity analytics enables greater investment returns than Markowitz-based portfolios at significantly less risk levels. The presence of significant signals means that the equity time series derives from a dynamic mixture of distributions rather than a single common distribution. In absence of significant signals, AI-enabled predictive equity analytics gracefully reverts to standard theory. AI-enabled predictive equity analytics extends standard theory to accommodate non-equilibrium dynamics as well as dynamic distribution mixtures. AI-enabled predictive equity analytics support is derived from two sources: A, statistically significant t-tests and ANOVA tests, and B, linear algebra, principal component method, maximal eigenvalue, and associated eigenvector. AI-enabled predictive equity analytics starting concept 0. Dynamic analysis is utilized to understand and visualize the morphing of the underlying statistical distribution or distribution mixture with respect to time and state space, aka discrete Fokker-Planck approximation. AI-enabled predictive equity analytics starting concept 1 is the underlying distribution supporting an equity time series, a single common distribution, or is a mixture of distributions a better representation. AI-enabled predictive equity analytics starting concept 2 can informative internal signals be detected for each observed point that supports single common or distribution mixture? Answer: yes. AI-enabled predictive equity analytics starting concept 3. Internal signals are detected for each observed point, then mapped to a set of 3 by 3 matrices with pairwise t-testing row and column averages to test single distribution assumption. 3 matrices are utilized: matrix A, Poisson point high variance; matrix B, high variance; and matrix C, nominal variance. The raw signal is recovered by adding matrices ABC. Filtered signal is matrix C. The set of matrices represents a single dynamic distribution if there are no significant column nor significant row t-tests. If, in addition, no retrospective change points are detected, then we have a single static distribution. The pointwise mapping into the set of 3 matrices differentiates AI-enabled predictive equity analytics from random matrix theory. In predictive equity analytics, the set of matrices A, B, C have consistent internal order. Conversely, if the mapping were uninformative, the resulting set of matrices would not be consistently informative and would be characterized as random matrices with at times spurious non-randomness at other measurement dates. Section 2. Distribution ink blots as informative leading to discrete Fokker-Planck approximation. Examples of the set of matrices A, B, C have consistent internal order. These are generalized distribution ink blots for stocks, ETFs, and mutual funds. Stock ink blots are generally associated with a full set of eigenvalues and associated eigenvectors that at times have one complex set. Testing for difference of means using pairwise rows and column combinations, where significant supports distribution mixture over single distribution. For ETFs and mutual funds, we see typically one set of significant pairwise row or pairwise column results for difference in mean. Drilling down to the raw data sets, we find that the mean represents sets where probability mass has been compressed in the middle and moved to the tails, causing asymmetric skew. Support for predictive equity analytics is as follows. For row averages, column averages, ANOVA and pairwise t-tests for difference in mean distributions. Retrospective change point. Eigenanalysis for changes in principal eigenvalue and associated eigenvector. Our discussion continues with 2 distinct cases. What makes AI-enabled predictive equity analytics unique? Said another way, what differentiates AI-enabled predictive equity analytics from other branches of investigation? The answer lies by contrasting random matrix theory and AI-enabled predictive equity analytics. The notion of informative mapping is the key differentiator. Note: AI-enabled predictive equity analytics, informative mapping is unique at each trade date measurement, in the sense that we are dealing with non-random matrices. If the data points are rearranged to a sequence other than the originally observed sequence of data points, the result is either a different informative mapping or complete loss of informative mapping. For example, replay the observed time series in reverse changes the original informative mapping or destroys it entirely. For an equity time series that has, a prior no signals, then logically any ordering is allowed, Since only distributional analysis is to be used, we perform similar analysis from last slide for the following time points: t minus 60, t minus 40, t minus 20, and t minus 10. From this information, we know the metastate effect, holding time constant at t equals 0. We want to calculate the effect due to time change, holding metastate constant. We can do this by rearranging our matrices into signal level and momentum for 3 contiguous time points. We have low signal with 3 columns of momentum, medium signal with 3 columns of momentum, and high signal with 3 columns of momentum. Given our data, we therefore have 2 sets of matrices and can measure change from t minus 20 to t minus 0 in time direction by signal level. It should be no surprise that we perform dominant eigenvalue and eigenvector analysis. There is a theorem from stochastic differential equation theory that states the eigenvalues and eigenvectors of the forward Kolmogorov differential equation are unique and form that basis to the current solution. See reference 17. We visualize a 3D depiction of continuous time varying Fokker-Planck equation and tri-signal PEA-AI enabled predictive equity analytics with dynamic state space 3x3x3 cube matrix. Up until this presentation, only the state direction transformation could be estimated with any degree of accuracy. For small enough time steps, one could assume no change in shape and waving hands that we are at full stationarity with a closed form solution. AI-enabled predictive equity analytics with dynamic state space key result, the ability to estimate the change in distribution in time direction, as well as estimate change in state direction at t equals 0. See Appendix for existence and eigenanalysis derivation for Fokker-Planck equation. Next, we have a sample AI-enabled predictive equity analytics report for Vanguard Total Stock Market Index Fund Institution VSMPX. Distribution ink blot changes from t minus 60 to t equals 0. We can see that in the distant past, as close trend trended down, numerous signal 1 indications increasing in value until series started to move up. A small burst of signal 1s as it continued up, followed by a quiet period. More recently, we observe a burst of signal 1's low intensity as the time series upward behavior weakened. Sample AI-enabled predictive equity analytics report for Vanguard Total Stock Market Index Fund Institution VSMPX continued. First, notice the series has not moved much, staying in the range 332 to 339, so few prospective and few retrospective signals were expected. The retrospective change point at -2 is up behavior at close price, 329. Examining the trend in average return for raw signal matrix, ABC reveals strengthening from 1.0003 to 1.0006, with filtered signal matrix C strengthening from 1.0008 to 1.0009. The retrospective change point indicates long-run forecast of up behavior from 334. Our Merton's sufficient statistic for investment return value, defined as the sum of condition probabilities, exceeds 1 and approaches 2 as shown. Of note is the slow accumulation rate. The variance-covariance weights used place money on stocks that are dead weights, creating a drag on return opportunities in favor of supporting stability in the form of weights as function of past variance. Covariance. Section 3. Current hedging of life and annuity products. Now we turn to applying AI-enabled predictive equity analytics to a life insurance or annuity product equity benefit guarantee. The standard assumption is of a single underlying common distribution. Index products are often hedged statically because cohorts can be identified and mostly independent, and the index options typically well defined by pure market parameters. Variable annuities are typically hedged more dynamically because the underlying liabilities are more dynamic, very long-term, with open investments funds instead of indices, and require integrated in-force reporting. Slides 20 to 23 credit to Frank Zhang from Equity-Based Insurance Guarantees Conference. Risk-neutral valuation and hedging under single distribution assumption. Key takeaways. A. Risk-neutral valuation and hedging are easier to understand because the liabilities grow at risk-neutral martingale. B. Risk management and hedging are to reduce the cost of guarantee's initial option value and to hedge to lock that in. C. If perfectly hedged, cost of guarantee equals cost of hedging, otherwise add breakage. AI-enabled predictive equity analytics aligns with option C, perfectly hedged in timing and amount, which results in smallest hedging costs. Delta dynamic hedging boils down to gamma risk under a single distribution assumption. Delta risk is how much an option's price may change when its underlying asset's price moves by $1. Gamma risk refers to the risk associated with changes in the delta of an option as the underlying asset's price changes. Higher realized volatility increases cost of dynamic hedging program under single distribution assumption. Sophisticated software and experience is required. Dynamic hedge cost is a function of both gamma and market volatility under single distribution assumption. Section 4. AI-enabled predictive equity analytics hedging for life and annuity products. AI-enabled predictive equity analytics hedging relies on dynamic change point prediction, detection, and not on variance. AI-enabled predictive equity analytics uses prospective, retrospective change point prediction each trade day and detects beforehand change point likely occurrence at which time proactive management is taken. It is a form of just in time and right amount of hedging, rather purchase at beginning of period using options or derivatives, and as such is least cost hedging solution. Outline: how to use AI-enabled predictive equity analytics to hedge equity benefit guarantee of 6% using Vanguard Total Stock Market Index Fund Institution VSMPX. Using prospective and retrospective signals from February 12, 2026, starting at 306.93, with indicated trades as of July 16, 2026, have compounded return in excess of 18%, with even more accrued return through August 7, 2026. Not only has the traditional hedge cost been avoided, a net excess of 10%, which allows for transaction costs, goes into the general account. To summarize, AI-enabled predictive equity analytics with dynamic state space framework enables the user to avoid market downturns as well as capture upturns through prospective change point prediction and estimation of eigenvalue, eigenvector to determine retrospective change point behavior with highest accuracy. Key takeaways: equity time series contains signals that can be sufficiently measured and mapped to a set of matrices: raw signal matrix ABC, filtered signal matrix C, and variance matrix AB. Mixture of distributions for equity time series must be tested for rather than assuming single common underlying distribution, where no prospective change points and no retrospective change points are detected. Then AI-enabled predictive equity analytics gracefully reverts to single distribution theory. Using change point prediction, detection is called dynamic diversification and is the optimal portfolio framework when significant signals are present. AI-enabled predictive equity analytics enables just-in-time hedging, which is the least cost hedging methodology. Lastly, we have predictive reports that are easy to use and interpret include: 1. Retrospective change point sum conditional probabilities typically equals 2 for a perfect forecast. 2. Prospective change point sum conditional probabilities exceeds 1, typically 1.5 or greater, but mileage varies. 3. Graphs, matrices, and 4. Dominant eigenvalue, eigenvector. To learn more, visit https://trisignalpia.com.